This video is going to cover page 5 in your packet, which is actually the first page of this packet because we started a new packet with the same unit. If you'll notice at the top of the page, it says do this whole column first, and then over here it says do this whole column last. This page is going to deal with wholes and vertical asymptotes, and also how to distinguish when is it a whole and when is it a vertical asymptote. So first thing we need to do is factor this expression. Let's go ahead and take a minute to factor it. Okay, on number 1, when you factor it, it's going to take a couple of steps. The first step is your GCF. After you do your GCF, you do your trinomial factoring, and you get this. Question A says, before you cross out any factors, where does it appear the graph is undefined? Remember, undefined is when you have a 0 in the denominator. If there's a 0 in the denominator, that makes it undefined. So our undefined areas are at x equals -4 and x equals +1. It's undefined there. Next question, do any factors cancel? What are they? Well, yes, in fact, x plus 4 does cancel. That's how we're going to do the left-hand side. I'm going to go on and continue down the left-hand side, and then I'm going to come back and explain what all of these mean. Number 2, factor and simplify. So once again, we have a GCF here. I'm going to factor out a -x for my GCF. Okay, so I have factored it, and once again, it took a couple of steps of factoring, took out my GCF, factored the trinomial, took out my GCF, factored the perfect squares. Okay, before you cross out any factors, where does it appear the graph is undefined? It appears it's undefined at 0, -4, and +4. The 0, some people forget about this one, but that x, which is by itself, remember it could be written as x plus 0, and that would just give you x equals 0 as far as where is it undefined. So don't forget about that one. And then the +4, -4, obviously this one has a -4, this one has a +4. Okay, next question, do any factors cancel? Well, yes, in fact they do. This x plus 4 cancels. So the x plus 4 cancels. Let's go on to the next one. Same thing, we're going to factor the numerator, factor the denominator, and see what we get. All right, so I factor it out. Where is it undefined? I look at my denominator, and in the denominator, -3 and +1 would make that 0, so those are where it is undefined. Does anything cancel out? Yes, the x plus 3's cancel out. Okay, last example. All right, so I factor it out. I look at my denominator, and it is undefined in 3 places, 0, -2, and +1. Next part of the question, mine fell off. It got moved from formatting, but it's does anything cancel, and what are they? Okay, let's look. Does anything cancel here? Yes, it does. This x and this x do cancel out. And so, yes, the x equals 0, or just in other words, the x does cancel. Okay, that is the left-hand side. Now, the instructions say, let's go to the right-hand side and do that now. It says, enter this function into your graphing calculator or Desmos and look at the graph and notice where any discontinuities may be. Okay, all right, for the graphing portion, you ought to be comfortable and familiar with graphing both on your graphing calculator and on Desmos. So for this first one, I'll show you on the calculator. For the next one, I'll show you on Desmos. Why don't you get at your calculator so that you can follow along? Okay, on your graphing calculator, there are 2 ways to enter these rational functions. The way that I did it, and you can see up here on the screen, is I just put parentheses and a division bar and then parentheses. And I put parentheses around the whole thing in the denominator and parentheses around the whole thing in the numerator. That's one way to do it. The other way is, remember on your calculator, if you go to the green alpha button and then hit the y equals button, you get this menu with the fraction options. Hit enter. And now you have the fraction bar up here. And so you can also enter this equation this way if you'd rather do that. But I already have mine entered with the parentheses, so I'm just going to do that. All right. Let's take a look now. If we graph this on our graphing calculator, make sure your plots are turned off and make sure there's nothing else down here. And if you just throw your calculator in your backpack without the lid on it, like I do sometimes it puts stuff here. So just double check, make sure there's nothing here. Okay, because now we should be able to go into Zoom Standard and we will get a graph of what this function should look like. Now, looking at this graph, you should be able to see that there's going to be a vertical asymptote here at x equals 1. Okay, it's not drawn, our calculator does not draw it, but that's where that vertical asymptote is going to be. So back to the worksheet for a second. The vertical asymptote, where are we? We are on number 1. It says enter the function in your graphing calculator and look at the graph. Notice where any discontinuities may be. Now look at the table. Okay, so just a minute. We're going to look at that table in just a second. But let's write down that there is a vertical asymptote at x equals 1. If you look over at your information over here, see, you already had that x equals 1, so you knew it. Well, what happened to this -4? Let's look at that graph again. At -4, there doesn't appear to be really anything going on, but actually there is. So I'm going to show you a couple different things. One thing is you can go to a table. You have a table button on your calculator. So if you go to the second and then hit that graph button, you will get a table to come up. And you can just, with the arrows, scroll up and down to different numbers. You can also do a table setup, and I can show you that later if we need to. But right now, x equals 1 has an error because it's undefined. And so that's what our calculator is saying. It's saying it's an error, it's undefined. We also still have something going on at -4. It didn't show up on our graph, but it is showing up in the table. Well, guess what? It will show up on our graph. Click the graph button again. And when you do that, it looks like this because we are in the standard zoom. If you go to Zoom Decimal, and so Zoom Decimal is number 4. Look what happened. Did you see that? There is a hole in my graph right here. And that is exactly what we call it. We call it a hole. It just seemed to break. Well, what happened was there was supposed to be an asymptote here. But that asymptote got canceled out of the fraction. We crossed it off. So when we crossed it off, we got rid of that asymptote, but what was left was a little remnant of it, a little hole. We will draw that hole on our graph. Just realize that is a hole. It used to be a vertical asymptote. We crossed it off the fraction. It is now a hole. So here on our handout, we have a hole. And the hole is at -4 something. Okay, well, what's the something? Well, let me tell you. There are some ways to calculate it. And the way you calculate it is you plug in to this fraction, but without the things that you canceled. So in other words, I'm going to plug in a -4 here, and a -4 here, and a -4 here. So I'm going to get -4 times -2 over 4 times -5. So I get a +8 over -20. +8 over -20 reduces down to be -0.4. Let's go back and look at our calculator. -4, -0.4. That sure looks pretty close to -0.4 to me. Now, if we wanted to check the table, we can check the table. Here's what I'm going to show you how to check that table. So go back into the table, go to second, graph, which is table, and you have this. Now, we said it was going to be 0.4. It's between -0.6 and -0.18, so that's pretty close. But if we wanted to get closer, we can go to table setup. So second, table setup, and let's start at -3.5. And let's change the table. Instead of changing it by 1, let's change it by 0.1. And now let's go to the table again. So go to second, table. So what I did is I'm setting it up. I want to look for my -4. I'm going to have to scroll a little bit. Okay, so I set up my table to count by 0.1, and what that did is it showed me I still have that -4 is still undefined. But what I was wanting to do is see, was I right in my calculation? Well, look, this is a -0.42, and this is a -0.37, and this is somewhere in the middle. Probably -0.4 is a pretty good answer for that. So that is a hole in the graph. When you graph it, I'll show you what it looks like. So ours, we saw the graph a second ago, and what it's going to do is we're just going to draw it as a hole like that. We're going to put a little circle there and draw our hole like that. And then the other side just went up on the other side. This one had a little bit more of an angle to it, but that's essentially, you get the idea. The idea is when we show it by paper and pencil, we put a little circle, and it's a hole. It is where the graph is not. It's like when we used to have an open dot and a closed dot. That's an open dot. It's not there. Okay, let's look at number 2. I'm going to tell you that, remember, anything that cancels out becomes a hole. So in this case, my -4 canceled out again. That was a hole. To find my y value, I would take -4 and I would plug it back in. So I'm going to do that just to show you. So if I take -4, I get -4, that's a +4, times 4 plus 1 is 5. And on the bottom, I have a -4 times a -4 minus 4 is -8. So I have a +20 over -32. And if I put that into my calculator, I should get a hole at -4 and -0.75. And actually, when we did this a minute ago, I forgot that, look, this also cancels. This x and this x cancels. The negative is still there, but the x does cancel. So when I plugged that in a second ago, I plugged it in with the 4. I didn't really need that, but it works out anyway, regardless. But with a 0, I should not put it in there because that's going to give me a 0. So I'm just going to put my 0 in here, and I got -1. Excuse me, I get 1 over -4, so that's -0.25. So those are my holes. My vertical asymptote is going to be at x equals 4. Let's fix it over here on the right also, that we also have a 4 at x. That created a hole as well. I will let you look at your calculator with that, see what it looks like. I'm going to jump ahead to number 3, and we're going to look at number 3 on Desmos. Okay, so number 3, what's happening here? The thing that is cancels, that is the hole. Whatever didn't cancel is still there. That is still a vertical asymptote. Let's look at it on the graph and see what we see. Okay, here I have another graph, and once again, doesn't have it drawn in there, but it looks like that vertical asymptote is going to be right about at +1, right? And if we look at our paper, that's what we have on our paper, vertical asymptote at +1. Hole, -3 something. Now, if we didn't see it on our paper, we honestly wouldn't find it. You have to at least have a head start of where is it before you can look on the graph, because if you don't know where to look, it's literally looking for a needle in a haystack. You're not going to find it. But we know it is at -3, so we're going to go to the graph and look. All right, let me show you how to look on Desmos. You can click on the function at Desmos, and it tells you what your coordinates are. So we're going along, and it's telling us what coordinates we have. Wasn't it at -3? Whoop. There it goes. Okay, so back to that needle in the haystack. You would not know where to look, but since we have it on our paper, we can zoom in our attention onto -3. we're just going to kind of go along here and see where it is. If we weren't paying attention, we wouldn't see it. But if we go slowly, once we get there, we can see that it is undefined. And look what else Desmos does. Over here, it was a solid dot, okay, because it's there. You get to the undefined portion and it changes. It is now an open dot. Just like in graphing, that open dot says it's not really there. So that's how you would find it in Desmos. Of course, Desmos also has a table, just like our calculator had a table. So what we do is we click on the function we want, we click on the settings, and we make it into a table. And we have this. We have that at 1, it is undefined. We knew that. There's an asymptote there at 1. What we thought was something was going on at -3. -3 is not on our table, but we can put anything into that Desmos table that we want. So I can just put a -3 in there, and it tells me it is undefined. And so now you've seen it on Desmos and you've seen it on your calculator, you should know how to find that. And again, where is it? What's the coordinate for it? Well, we need to take that -3 and we need to plug it in and we need to find out what we get. So I'm going to plug it into this. I'm going to have 2 times -3 minus 2 is -5. And -3 minus 1 is -4. That is -10 over -4, which is positive 2.5. Let's go back and look at Desmos again and see if that's where it is. Pretty close. So here we are, and I was undefined there. There it is, undefined, right there. If I look on my graph, sure looks like about 2.5. These are counting by halves. But I can also scroll, look, -3.05 and positive 2.49. And then I go a little bit the other way, and I get -2.93 and positive 2.509. Pretty close. And then, yes, it is at 2.5. They just won't tell us what it is because when they calculate it, they are plugging in with the original things, and that's going to give me an undefined. But if I do it without those, I get an actual number, so I know where to put it. Because when I graph this by paper and pencil, I need to know where it is. Okay, that is how you find vertical asymptotes and holes. The last one, if we wanted to finish this out, our last one here, our hole is what canceled out. That was a 0 something. Our other ones are still vertical asymptotes. So that's x equals -2 and x equals +1. Those are our vertical asymptotes. Our hole is at 0 something. What is the something? Well, I'm going to plug it in. There's no 0, no x there, but this is going to be 2 times -1. That is 4 over -2. Should be a -2. I believe this is the other one I had on Desmos. So let's look and see if we can see a hole at 0, -2. Okay, I forgot. Sorry. This comes out to be a -2. That's true. But look, I forgot. There was a negative sign there originally. So that makes that whole thing negative. So now we're up to a +2. So our hole should actually be at 0, +2. Once again, let's go to Desmos and see if that's where it is. Okay, here's 0, here's +2. I'm going to just kind of scroll around there and see, and there it is, 0 undefined, but it is at 2. We can see quite clearly that that is at 2. So that is how you find holes. The holes are the ones that cancel out. The x-intercepts are the ones that, the vertical asymptotes are the ones that stay.